Welcome back. This is Mrs. Rewrite with Algebra 1 Honors. Today's lesson is 4-4, the slope formula. Alright, so the slope formula is the change in y over the change in x, right? Change in y over change in x. Delta just means change, right? So it's your y2 minus your y1 over x2 minus x1. So your slope equals subtract your y's over subtract your x's, okay? It doesn't matter which one's 0.1 and which one's 0.2 as long as you stay consistent. All right, so we are using the slope formula. So in this problem, we are using the following points. So use points A and B, so A and B. So point A is -3, 5, and point -3, -5, sorry. And point B is 1, 3. So we'll say x, y, we'll call this point 1 and this point 2. So y2 minus y1 over x2 minus x1, bam, 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 8 over 4, which reduces to 2. So your slope is 2. Okay, let's use A and C. So we have the points -3, -5, and 2, 5, xy, we'll call this point 1 and this point 2, y2 minus y1 over x2 minus x1, bam, 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 10 over 5, which reduces to 2. Use points B and C. So B is 1, 3, C is 2, 5, xy, 0.1, 0.2, y2 minus y1 over x2 minus x1, right? 5 minus 3 is 2. 2 minus 1 is 1, and 2 over 1 is 2. So you can see that no matter which 2 out of these 3 points that I choose, I'm always going to get that slope of 2. So if I go back to the picture and just look at my rise over run. So it goes perfectly here, and we're going up 1, 2 over 1, 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 up 1, 2 over 1. Do you guys see that? It's up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. This one has a slope of 2. So your slope is y2 minus y1 over x2 minus x1, or rise over run. Is the slope of the linear function constant? Explain. Yes. It doesn't matter which 2 points you choose, they will always give you a rate of change or slope of 2, right? Your rate of change or your slope is 2. It's always 2 on that problem. All right. Estimate the average slope of particular sections of the quadratic function y equals x squared represented in the graph at the right. So what is the x-coordinate of D? So D is here. D is at 0, 0, right? The average slope between D and E. Well, what is E? So E is 1, 1. So D to E, 0, 0 to 1, 1. We're rising 1, we're running 1, right? Slope of 1. Make sense? So F, where's F? F is at 4, 16. So going from E to F, we're rising 15, we're running 3. And 15 over 3 reduces to 5 over 1. From E to F. So E, oh, did I just say, I just did E to H. My bad. It says E to F, not E to H. So I'm rising how many? 3. I'm running 1. So that's a slope of 3. Nobody even said anything to me. Come on now. Y'all have to catch my mistakes. I'm still sleeping. It's early. You guys are like, I'm too tired to catch them, right? It's too early in the morning. All right, so from F to G, well, what's G? G is 3, 9. So from F to G, we're rising. We're going from a height of 4 to a height of 9. So that's rising 1, 2, 3, 4, 5, running 1. 5 over 1 is 5. All right, from G to H, what's that?
For F and for H, the coordinates of F, it's supposed to be 2, 4.
For the coordinates of F? Oh, that's why I messed up. I messed up more than one spot. That's what it was. I knew I messed up because I'm like, why am I doing this? Got it. So for F, it was 2, 4. There's where I messed up. Thank you so much for finding that. All right, so from G to H. G to H, we're rising. We're going from a height of 9 to a height of 16. So we're rising 1, 2, 3, 4, 5, 6, 7. We're running 1. 7 over 1 is 7. Does that make sense, guys? How are the x coordinates of each pair of points given in the table related? The x coordinate of the second point is 1 unit greater than the x coordinate of the first point. Right? They're going up by 1, up by 1, up by 1. For y equals x squared, make a conjecture about how the average slope between 2 points whose x coordinates are 1 unit apart is related to the x coordinate of the point with the lesser x coordinate. Hint. Write and simplify an algebraic expression for the slope between x2 and x plus 1 squared. Is the slope of the quadratic function constant? Okay, so if I'm doing changing y over changing x with this, all right, so changing y over changing x. X minus x is gone, so it's something over 1. So what is this? This is going to be x plus 1 times x plus 1, which is x squared plus 1x plus 1x plus 2x plus 1. X squared plus 2x plus 1 minus x squared. Gone. 2x plus 1 over 1 is going to be your slope. So your slope is 2x plus 1. So let x represent the x coordinate of the point with the lesser x coordinate the average slope between 2 points whose x coordinates are 1 unit apart is 2x plus 1, right? We just solved that. The slope of a quadratic function continually changes. So it is not constant. It's only constant if it's linear. Well, let's zoom this out a little bit. It's only constant if it's linear. Use your conjecture to estimate the average slope between these 2 points in y equals x squared. Explain your work, then use the slope formula to check your estimate. Okay, so the lesser x coordinate is 8. You're going to have 2 times 8 plus 1 equals 17. Right? So using the formula, the average slope is 17. Because you're just plugging into 2x plus 1, right, guys? Now let's actually do this. So 81 minus 64 over 9 minus 8. 81 minus 64? $17, right? 9 minus 8? 1. 17, so that checks out. Make sense? Will your conjecture hold for negative x coordinates? Give an example or counterexample to support your answer. Yes. So if I use the point 1, 1 and 2, 4, negative 2, 4, using negative 1, 1 and negative 2, 4, the average slope would be 2 times negative 2 plus 1, which is negative 3. Using the formula, the average slope would also be negative 3. So let's prove it. So 4 minus 1 over negative 2 minus negative 1, bam, bam. 3 over negative 1 is negative 3. So you're going to get the same thing if you plug it into your 2x minus 1 or your slope formula. Find the average slopes of pairs of points with negative x coordinates that are 1 unit apart. Arrange them in order from least to greatest with the slopes from part A. What do you notice about the average slopes of the x coordinates increase? Will the average slope ever be 0? Why or why not? Okay, so as the x coordinate increases, or x coordinates increase, right? Increase. The average slope increases. The average slope must be 0 at some point because the average slopes go from negative to positive. So it has to be 0 to switch from the negatives to the positives, right? At some point. All right. Estimating the slope of sections of exponential functions. All right, so what is the coordinate of the x coordinate of I? 0. The x coordinate of j, 1. X coordinate of k, 2. X coordinate of L, 3. Right? I'm just stealing their x coordinates. Average slope between I and j. So from I to j. We're rising 1. We're running 1. So it's 1, right? Average slope between j and k. From j to k. We're rising 2. We're running 1. So it's going to be a slope of 2. Average slope between k and L. We're rising 4. We're running 1. So a slope of 4. From L to M, we're rising from a height of 8 to a height of 16. That's rising 8, running 1. So a slope of 8. How are the x coordinates for each pair of points given in the table related? So the x coordinates are going up by 1 each time. They increase by 1. For y equals x, 2 to the x, make a conjecture about how the average slope between 2 points whose x-coordinates are 1 unit apart is related to the x-coordinate of the point with the lesser x-coordinate. Okay, so let x represent the x-coordinate of the point with the lesser x-coordinate. The average slope is 2 to the x. Use your conjecture to estimate the slope between 8, 256 and 9, 512. Use y equals x to the y equals 2 to the x. Explain your work, then use the slope formula to check your answer. All right, so we're looking for the lesser x coordinate, right? So what am I plugging in? Plugging in 8, right? So y equals 2 to the 8th. What is 2 to the 8th? So you've got to break out a calculator, or if you don't want to break out a calculator, 2 to the 8th is 2 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 2 times 2 is 4, 4, 4, 4, right? 4 times 4 is 16. 16 times 16 is 256. So it should be 256, right? So y equals 256. So then using the formula, y2 minus y1 over x2 minus x1, you're going to get 256 over 1. So you're getting the exact same answer. Will your conjecture hold for negative x coordinates? Give an example or counterexample to support your answer. So, what if we used the point -1, 1/2, and -2, 1/4? The average slope would be 2 to the -2, which is 1/4, right? Because anytime you have a negative exponent, it's 1 over that number to the positive exponent, right? A negative exponent is 1 over that number to the positive exponent. So 1 over 2 squared, which is 1/4. Okay? Using the slope formula, you'd have 1/4 minus 1/2 over -2 minus -1. So that is also going to give you 1/4. So yes, this works. Find the average slopes of pairs of points with negative x-coordinates that are 1 unit apart. Arrange them in order from least to greatest with the slopes from part A. What do you notice about the average slopes? The slopes of the as the slopes of the x-intercept coordinates increase, do you think the average slope will ever be negative? Why or why not? So, as the x coordinates increase, the average slopes increase. The average slope will never be negative because the average slopes all have positive values and those values are continually increasing. Make a conjecture about the average slope of various sections of each graph. Use sections that have endpoints in which x coordinates are 1 unit apart. All right, so on this one, so which points are you guys going to choose on this one? So, so if I'm choosing x coordinates that are 1 unit apart, so say, what if I wanted to choose like this one and this one, right? Right? So I use the lesser one, the lesser x coordinate, and have y equals 2 times negative 3 squared. Negative 3 squared is 9. 9 times 2 is 18, right? That makes no sense. I'm not supposed to plug it in here, am I? Nope. Okay, anyway, so honestly, the easiest way to do this is to just do slope. So we're going down what? We're going down how many? Rise over run. We're falling how many? Going from a height of 18 to a height of 8. We're going down what? Down 10. We're running what? 1 in the positive direction. So this has a slope over here of approximately negative 10. Right? So over here, that's our changing point, right? And then like going, how about up here? What's my slope up here? So if I was using, say, these 2 points, my slope is approximately rise how many? Rise 6, run 1, slope of 6. Right? So on this part versus this part, because we're kind of just asking like what all of them are, right? So over here, you're basically going to have like almost like a horizontal would like be like pretty close to like a 0 slope, and then it starts increasing more steadily. So your slope keeps changing. So like if you were here, you're rising 6, you're running 1. So this has like a slope of 6 right here. Where if you're going from here to here, this has a rise, what, 18? Rise 18, run 1. So you see how the slope's constantly changing? All right, so your additional practice is what your homework is, so 201 and 202. And these problems here are way more straightforward, okay? So just to kind of do a couple of them with you guys, find the slope of a line that contains each pair of points. So you have x, y, 0.1, 0.2. These are straight up plug and chug. So you're going to have negative 3 minus 8 over 1 minus 2. Negative 3 minus 8, bam, bam. Negative 11 over negative 1, bam, bam, right? It's just going to be 11. So you have a slope of 11. Okay, what about if we did one of these? So if I was doing this one, does it show a linear relationship? Find the slope. So let's look. It looks like we're going up 1 over 2, up 1 over 2, up 1 over 2. It's not exact. Let's see. I think they just draw ugly pictures, but let's check it out. So if I'm going to this point and this point, we know those points. You're rising 1, 2, 3. You're running 1, 2, 3, 4, 5. So rise 3 over 5. So it's up 3 over 5, up 3 over 5, up 3 over 5. So your slope is 3/5. Okay, over here you can do it without a graph, just looking at my change in y over change in x. So here we're adding, think about money, it makes more sense. Get it, huh? Money makes more sense. So 25 cents gets you to $4, so $1.25 to get to $5. 5 plus $1.25 is $6.25. $6.25 plus $1.25 is $7.50. So you're definitely going up $1.25 each time, right? So $7.50, $8.50, $8.75, perfect. And these are increasing by $1 each time, or 1. Change in y over change in x. 1.25 over 1 is 1.25, or 1 1/4 as a fraction is 5/4. Make sense? 1 1/4 is 5/4. Multiply and add around the world. All right, so I think that you guys should be pretty set with this homework, hopefully. And so then we are going to end this lesson, and then we're going to pick back up at 4.5. So I hope you guys enjoyed the lesson on 4/4. Like and subscribe, and have a great day.